Exaggerated, that's what you assume. The story's over now, I must conclude. I am conflicted, watching where I step still, hanging in the balance. Not the life I want to live, I want to take it all. Standing tall, fear outweighed the person you are. Oh, break out, I've got to see. Spent all my life holding all of it closely. I played it innocent, a feel of discontent. I'm finally facing it all, fearless. Over the edge, feel like I'm floating through the air. The pain I felt is paid for, all is said and done. Oh, I am restricted, fixed upon the web. I need to kick the habit that my mind is breathing in. Break out, I've got to see. Spent all my life holding all of it closely. I played it innocent, a feel of discontent. I'm finally facing it all, fearless. Burning the bridge that keeps us. I'm here and I'm feeling fearless. Exaggerated, that's what you assume. The story's over now, I must conclude. I am conflicted, watching where I step still, hanging in the balance. Not the life I want to live, I want to take it all. Standing tall, fear outweighed the person you are. Oh, break out, I've got to see. Spent all my life holding all of it closely. I played it innocent, a feel of discontent. I'm finally facing it. A feel of discontent. I'm finally facing it. All I've got to see. Spent all my life.
Hey everyone. Hey, Greetings, everyone. Uh, I'm doing really great. Hope you too. We've got a couple of viewers on YouTube. That's awesome. Thank you so much for joining me on live. We are going to do some malware analysis. So that's what I mentioned on the thumbnail, right? So let's do some malware analysis. It's gonna be an interesting session. Um, yeah, let's make it more interactive. If you are joining on the stream, you may ask uh, the questions to me. It is also an ask me anything session, so feel free to ask your questions. Throw it on the chat box. I'll try to answer them. Okay. Mm, yeah. Actually, if you are newly joining or newly watching this stream, so let me introduce myself. My name is Perumal Jagan. I'm a security researcher working at an MNC. I have a day job, and I I'm, I actually uh, wanted to teach cybersecurity. Wanted to give back to the community. So I chose to do this YouTube channel. I chose to YouTube it, and that is where I got into this. Um, I really enjoy doing cybersecurity. I really do love cybersecurity. In fact, uh, it's a fascinating field. To be honest with you all. Um, in fact, let me introduce. I mean, let me give you an insight about my career. I was actually working in. Uh, uh, I mean, my first company. It was actually a conglomerate. I was working in an IT company. There, I was a part of a firewall team. I was actually a network security engineer, configuring firewalls, opening the ports, allowing access uh, to certain websites. So that is what was my role. Uh, and I stayed there for a couple of years, and I literally learned the fundamentals of networking, the networking basics. So I would say that was the role paved me the way to cybersecurity. Since I got the the basics of networking, it was not harder to get into cybersecurity, because as a beginner, if you're trying to get into a cybersecurity, you must be learning few things. You must have learned few things like um, operating the Linux I mean, working on the Linux operating system, uh, having strong fundamentals on networking, knowing some basic programming. So these are all some of the basic things that will add you a value when you are entering the cybersecurity. Since I was already since I already worked on a network team, it was not difficult for me to get into cybersecurity, as I said. So I got into cybersecurity. Um, During my initial days, I did not get. Uh, I did not uh, able to adapt it quickly, but uh, once I got the rhythm, I was able to quickly adapt myself and delved into this field. I would say one thing. What is cybersecurity? If you ask, I would say it's like an ocean. There are plenty of things to learn. Even you learn 24/7. Well, that's practically impossible. Even if you do so, you wouldn't be covering the whole thing. There are enormous things in cybersecurity. I would say enormous is the word to use, because it's massive, it's gigantic. So there are there are plenty of specializations on cybersecurity. Everything is fascinating in my opinion. Um, so that's why I'm not limiting myself to do a particular thing, because I want to explore as many things as possible. That's why I would be doing a penetration testing at one video. I would be doing malware analysis on another video. I would be doing forensic analysis on one video. So because I love them, I love doing all of these things if it is interesting enough. um, so that's the idea behind this. So today we are planning to do some malware analysis, right? um, all right. I think uh, I need to start now. um, okay. uh, I previously made a couple of videos. It was recently launched on my channel. It was about the basic static analysis, right? We actually did some um, try hack me room to learn the basic static analysis, right? So why don't we go and do the same try hack me? Or think I'm just thinking like what I can do. Can directly take one malware analysis Sherlock and solve, or taking a path of doing the fundamentals on try hack me, because it's a stream. I don't want you guys get bored. I don't want to bore you guys. So what I can do, probably why don't we straight away doing one challenge, because um, I already gave the commitment to do the try hack me rooms about malware analysis. If you've seen my previous stream, you might know. Um, so I'll be doing those try hack me rooms about malware analysis in near future. But how about doing a Sherlock, taking a live Sherlock, uh, getting my hands dirty? I think that's what I'm planning to do right now. I hope you guys can able to hear me properly. Um, let me check my stream before I start doing all these things, okay? Because I don't want to ruin my stream, because sometimes after I do all the things, I realize like it was totally spoiled. I wouldn't be hearing any audio, or some video issues, or the screen I failed to switch. So I used to face all these issues. I guess, yeah, the audio is good. Okay, now let's start this. It's gonna be an interesting stuff. um, okay, let's do this. We do the hack the box. So we take a Sherlock, a malware analysis Sherlock this time. um, what I can do, let me share my screen. Okay, so before I starting the stream, I would want to inform you that um, I also do parallelly record this stream, so that I'll be able to make them as a separate videos. Anyway, I'm just gonna post them on my channel, but I want to record these things as a video as well. So I'm planning to record this. So bear with me. Um, I have my VM ready and everything. So let's do this. Okay. All right. I'm gonna hit the button. Come on. Hey there, hello everyone. My name is Perumal Jagan. I'm happy to see you once again. Today we are going to do a malware analysis. We are going to take a try hack me Sherlock challenge. It's gonna be a malware analysis challenge, and we are going to answer some of the questions. asked by Hack the Box. Okay, so that's the plan, and the name of the challenge is going to be Malevolent Mod Maker. Okay, so let me go and share my screen. I hope you guys can see my screen right now. So this is about Sherlock. Sherlock is actually, for those who don't know what is Sherlock, I hope you know the character, right? Sherlock Holmes, right? So it is all about investigating a crime, investigating an incident. So the Sherlock in Hack the Box resembles that. The term resembles that. A cyber incident happens and you are here to address the cyber incident. So they'll be giving you some artifacts are basically some files, some log files. So you need to assess them before answering the questions that asked by them. Okay, that's the concept behind this. And I'm gonna search this malevolent mod maker. That's the uh, name of the challenge, and you can see it's a VIP challenge. It's a retired challenge. So you in Hack the Box, you cannot uh, uh, record and publish their active category challenges, be it a machine, Sherlock, or a challenge. You cannot publish their active category things, but you can do their retired stuff. So this is actually retired recently, retired yesterday, I suppose. So that's why I decided to do this. Okay. uh, okay, I guess this works. So let me go and make sure I'm just getting into the folder. Come on. I've already created a folder Malevolent Mod Maker, and some couple of MD files you can see. I just recorded all these things in a separate file. Anyway, let's see. Let's read through the Sherlock scenario. Um Bob, a senior software engineer at Acme Inc., was taking a break from cutting AI code to check with his favorite gaming community. One of the New Year members shared a new program that can make mods for a popular game. Eager to try new things, when he ran it as an administrator, all of his files were deleted or replaced. He immediately called help desk, so they locked his machine. An incident responder was called. So looks like software engineer was behind this incident. It's apparently a malware incident. You could see that. So when he was trying to uh, uh, check out his favorite gaming community, he received a file, appears to be a mod maker. Then when he triggered that file, his machine got infected, and you can see the symptoms here. He ran it as an administrator, and you could see his files were deleted or replaced. So what kind of infection this is? So when you see Sherlock scenario, you must predict what sort of incident it could be. So maybe by seeing this, what I can say, maybe it could be a ransomware incident, because ransomwares typically do encrypt. The ransomware operators typically do encrypt their victims' files, sensitive files, so that they can ask their victim to pay some money to return the files that they encrypted. That's the concept behind this ransomware operations, the ransomware operators. So I got the file malevolentmodmaker.zip, so its size is 4 MB, and I also have some questions against me. Let's see the task 1. Right from the start, based on the incident details, the .txt file contents and the extensions appended to the .txt file. What type of malware infection is this? Okay, and so it's apparently it's going to be a ransomware infection. Let's see. What mechanism does MC modmaker 1.0.exe use to send information back to C2 server? So we are going to do the malware analysis, and you can see the file name here. It's an exe file, an executable, Windows executable file. What command does this exe run, suggesting that it mean to execute other binaries and scripts? And what's the value of API key contained within the URL suggests the enumeration? Okay. What domain is E2 server that serves ransomware payload? And you can see the name here, it's a ransomware apparently. While analyzing the exe, what format the data is returned to the seed server? Okay, I guess all these questions are about analyzing the malware. So we need to analyze this malware, but uh, let's see how to do that. Since it is a malware analysis, for those who don't know what is malware analysis, let me tell you, it's all about accessing an unknown executable file. Executable file, typically if you see open in a file, you won't be able to read or understand anything because it's a machine readable format. It is in the machine readable format. So there are certain tools to open the exe files or any binary files to read them. And when you are accessing these kind of unknown files, it's a best practice to do it on an isolated machine, on a separate machine. So what I'm going to do, I'm planning to do this analysis on a separate virtual machine. Okay, that's the plan. I already set up my malware analysis environment, and you can see the malware lab that I have. I have two machines here, a malware lab static and malware lab dynamic. So let me tell you what it is and how I build this thing. Okay, so let me open this. I'm gonna refer you a YouTube video that is gonna give you the idea how to build the malware analysis sandbox. The researcher name is Anuj Soni. He was the one, I actually referred this particular video to build my malware analysis lab. I also could make a video about building malware analysis lab, but I don't want to waste your time by doing it because there are plenty of resources to do that. And you can see it's the latest one. You can use this video, his video, to build your own malware analysis lab. So it is all about spawning a Windows machine, a fresh Windows machine on any hypervisor you prefer, then installing certain static and dynamic analysis tools. Okay, that is the gist of this video. So you can feel free to watch this video. So here is the title. The channel name is Anuj Soni. Okay, so I just wanted to give you an insight about building the sandbox. Okay, that's the idea. And another important thing is it must be isolated. So you must change your network adapter to a custom adapter. It should not be either bridge or NAT. It should be isolated. So I created a separate network called malware analysis. It's an internal network. So I put both my VMs in that malware analysis network. So these two VMs will be communicating each other, but it won't be communicating. They won't be communicating outside, either its host or any other machine. I want to preserve my host from infection, right? So that's the idea. And here is the static lab, and also it's a best practice to take a snapshot. So I have a fresh snapshot. So whenever I open this lab and run the executable and infect the machine, I can simply close the machine and I can restore the previous snapshot, which is a fresh one. So it's going to help us to revoke or restore the infection that already happened. Okay, that's the idea. Oh, come on. Let me start this static malware analysis machine. So it's a Windows 11 machine. Let's see. I also have the dynamic machine, but for the static analysis, I'm planning to use this one. For the dynamic analysis, let me open this. Yeah. Now you could see I logged into the machine and I got some fundamental basic analysis tools like x64 debugger, binary ninja for disassembling, HXD for hexadecimal reading, I guess. So I got some tools here. It's gonna help us eventually for the analysis. I'm not starting the dynamic lab dynamic machine right now, but before that, let's try to unzip it. Okay, maybe I can use 7-zip utility. 7-zip yes malevolent mod maker, and it's asking for the password, and the password is gonna be hack the blue. That's the password, and it's done. And you could see there are two files. One file is zip, another file is a text file. I guess this is a kind of a caution note. Maybe what I can do, maybe I can pass this file into my malware lab before I start doing this thing, right? I think that would make sense. Okay, let's do this. I'm planning to do one more thing, because I need to share file from this VM to my malware VM, right? So let me do one thing. I will create one SMB server, um, so that I'll be able to share my files across the VMs. Let me find a command to that. I got the impacket utility to do it. Let's see, so I have this command already. Command smb, yeah, here it is. So this is the command I used last time. So let me grab the very same command with few modifications this time. Okay, so 192.168.0.146 is my IP address, and SMB to support the username and password, and I'm also naming my folder something. So let's do this. I need to alter this command somewhat. What folder I'm going to share? I'm going to share this particular folder, right? So let me copy this, keep it in my clipboard. Control R SMB to do the recursive search, I guess. Okay, now I'm gonna go and enter my home directory followed by the malware directory. Then let me name this directory as mod maker. Okay, username and password and my IP address, the SMB server, SMB server.py. I'm using impacket SMB server script. Okay, entering. Now my SMB server is listening. Then what I can do, I can go here, and before that I need to go and change my network settings, right? So let me go and make it to bridged for a moment. Okay, it's a fresh snapshot, so it's gonna affect my system. So in the network analysis, the network adapter, I'm just making it bridged. Okay, now I can go here, maybe to the file explorer, and in this tab I'm just gonna type the UNC command 192.168.0.146. Can't find it. Let's see what's my IP config now. No, it's not yet up. How about go and restart this? I restart my malware lab so that the network adapter will come up. So let's wait for a moment. So it's up, so I'll be able to access this SMB share from my malware lab. All right, now I go to this. Before that, let me check my IP details. Oh, come on. It's not holding any IP. I guess there is a reason. I go to task manager, network and internet. No. Bluetooth or devices. I don't know. I actually missed somewhere. Home, not home. Do I need to make any changes here? Screen, storage. Oh, come on. Network and internet. Advanced network settings. Enable. Yeah. Okay. Now I have enabled the Ethernet adapter. Now if I check IP config, I got the IP address. Now I'll be able to 192.168.0.146 accessing the path over SMB. It's asking for username and password. If you remember the command, it's the same, my name. Now I can see the mod maker folder, but it says the folder is empty. Is it so? I got plenty of files here, right? Why it isn't showing any file over the network? View, show hidden items. I'm seeing the hidden items also, but I don't see this. Current file sharing are turned off. Network computers devices are not visible. Click to change. Network discovery is turned off. File and printer sharing. Okay. I think I disabled it for the best practices. Okay, let me. Now it is actually detecting my Wi-Fi router. Oh, come on. Mod maker. Can I see the files now? What could be a reason? I'm able to access the internet, but the files are not getting detected over SMB. Mod maker directory I can see, but not the files. Allow other on the network to read write files on the public folders. No. Your PC can find or can be found by other devices on the network. Allow other or on the network access files and printers on this device. I think it makes sense to disable these things. Allow others on this network to read write files on the public folders. Your PC can be found by the other network on the device. File and printer sharing. Allow others on the network to access the share files on the printers on this device. Okay, I guess I should find an alternate way to do it. Advanced sharing settings. So this is the current profile, the public networks. Even though I turn it on, I still don't see this. Let me Google this. Why files on SMB server are invisible while accessing from another Windows machine from same network.
Heute bist du nicht mehr da, jetzt ist das Rampenlicht. Tausende von Narben hab ich nun in meinem Gesicht. Farbe in der Haut, ja diesen Schmerz, den hab nur ich. I think we are different. Our love was so magnificent. I tried so hard to know as far I could ever go. I think
So they are telling about this setting up this private settings, right? You are on a metered connection. Some apps might work differently to help you save the data on this network. I guess that metered connection is causing this, but I don't know. Let's see. Because I have to enable that. Now if I go and refresh this, is it work? Is it gonna work? No. The IP address of my machine is 146. That's okay. Okay, I turn on this metered connection and come back to these profiles. Where are the profiles? I need to restore the previous settings. Come on, how to do that? So data usage. It's enabled, so I can disable them. More adapter options. No, not this one. Advanced sharing settings. Yes, this is what I was looking for. I guess these are fine. It was like this. The public networks was off. Okay, I think this is totally fine. I'm going to use another stuff now. So let me start a Python. Let's start a Python web server to share these things. Python 3 -m http dot server to serve the files on a default 8000 port. And now I'm copying the file name. I'm going to this folder, going to this VM 192.168.0.146 8000, and here are the files. I can simply download them. I'm gonna keep them. Yes. And this one not working anymore, so let me go and unmap it. Oh, come on, I accidentally clicked it. It is trying to access the path which is not exist anymore. It's gonna take some time. Okay, I guess I have downloaded this file, Malware mod maker. Maybe I can go and store this file somewhere. Come on. Copy and I guess I can create a folder here, right? Folder sample. I call it sample. I cut and paste. Users, desktop, sample. Yeah, I guess it's done right now. So I want to make sure these settings are totally fine, because I don't want to miss this thing. the metered connection. Let me check that one as well. You are on a metered connection, that's totally fine. And now I got the file. All I need to do is to open this file and start doing the static analysis. Before that, maybe I can hold on a sec. Okay, come on. Okay, I'm not able to unlock this. Anyway, that's totally fine. I'll do one thing. I will go and start the settings. Do I have 7-zip? Yes, I do have the 7-zip. So I have all the necessary tools that are required for this. But for now, let me go and change or restore the settings. VM settings, network adapter. I'm coming to custom network, and malware analysis is the network. Okay, and now I guess I shouldn't be able to see IP config. Come on. I do see the network still, but I want to disable the network adapter because that was the state previously. How to disable it? Ethernet. Come on. How to disable the network adapter? Yes, here it is. Okay, now I have disabled the network adapter, because even if I trigger this sample accidentally, it's not gonna affect us. Okay, now you can see the network adapter is not configured, and if I ping some public IP, I wouldn't be able to ping because it is isolated completely. Okay, now it's time to start the assessment. I think this is the end of the first part, so I'm going to stop this recording now. I'll be keep streaming now. So before I start my next recording, I think this is the time to end the first part. So yeah, I think this is the end of the first part. So here we have seen how to prepare your virtual machine for the malware analysis. I also referred a video of Anuj Soni that's going to help you to set up your own malware analysis sandbox. Okay, so I'll end this recording here, but you will be seeing the stream still, because I'm streaming. I'm recording while I'm streaming, so you'll be seeing me on stream. And we are going to do the static analysis now. But yeah, I think we got 4 people. I think this is the maximum number of people that I've got on the stream. My heart is filled with gratitude. Thank you so much for your support. Okay, I really appreciate that. All right, I think this is time to record the second part. Okay, let's do it. Maybe let's start here. Hey there, hello everyone. My name is Permal Jagan, and we are doing a malware analysis. In the previous part, we've seen how to set up your sandbox and how you can build your own sandbox. Watch the Anuj Soni's video. I actually referred it in my previous part, so go and check that out. So today we are going to extract the sample and see what we are up against, how we can do the probably the static analysis. Let's start with the static analysis first. Okay, so that's what we are planning to do. Without further ado, let's get in. So I start sharing my screen, and you can see I am on my malware sandbox. So I have already copied the sample, and you can see this particular machine is isolated, not connected with any network. And let me remove this. Yeah, yeah, okay, fine. Now I go to my desktop, uh, sample, and here is the file. So I need to unzip this file first. So let's start and unzip this. Maybe I can extract this one with 7-zip. How about that? Yes, 7-zip, extract here, and the password is hack the blue. Okay, that's the password provided by hack the blue. Okay, now I could see uh, the file. There are two files, danger.exe and danger.zip. The danger.txt is actually a caution note, potentially a caution note, but you can confirm that. I also need one more tool here, but I guess I failed to install it. But okay, that's fine. That's fine. Do I have a file utility here? File is not recognized as the commandlet. Okay, but not a problem. Let's see the properties. I think by seeing this is actually simply a caution, a text file. So no problem, we can open it because there is another zip file. I think that file potentially has the malware. Okay, let's open this caution note. Let's read through it. Okay, I prefer opening it with another text editor. Let's see. Let me change to open all the text files with Sublime Text. I really love to use Sublime Text. Okay, now I could see the caution note here. Dear user, this text file is not warn you that the zip file contains a software that is going to interact with your okay. This text file is to warn you that a zip file contains the software that is going to interact with your computer and files, malware. This software has been intentionally included for educational purposes and is not intended to be executed or used otherwise. Always handle such files in isolated, controlled, and secured environments, and that's what we did right now. We just isolated the file. It is strongly recommend you proceed by running the sample in controlled environment, for example, a pawn box or isolated VM. Only unzip the software in this controlled environment using the password provided. Unzip the file in the VM and enjoy analyzing. So it is advised to unzip the danger.zip file only on the secured VM. Please exercise extreme caution. The zip file contains the software, is password protected for your safety. The password is, so here they gave the password also to unzip. It is strongly recommended that you don't extract or execute the contents of the zip file unless you understand the risks involved. By reading this file and using provided password to unzip the file, acknowledge and fully understand. Okay, so there are some disclaimer as well. All right, we got the password for this zip file, the danger.zip file. So let's start opening it. I go here. I see more options. 7-zip, extract here. So it's gonna ask me the password, and I have added the password. And now when I click OK, oh come on, I could see bunch of files. It's quite confusing. Let's see. These 3 files we already own. I don't know about this data text, bruh.exe, another exe, and a text file ends with go team extension. I don't know what is this go team means. Maybe I can do one thing. I'll remove all these things. I'll just try to unzip this again within a folder. 7-zip, extract to danger. Again, I'm pasting the password, and now I could see a folder. This folder is actually holding all the files that we need to access. Okay, all right, fine, totally fine. Let's do one more thing. Do I have a commander? I don't have the commander utility. It would have been so easy for us to access a file with commander, but not a problem anymore. We got a couple of files. bruh.exe, it's an executable. goteam.exe is also an executable, and mc modmaker version 1.4.exe. This looks like the mod maker application. In video games, mostly, they will be having a content called mod to enhance or to add some features to that video game. So there are some official legitimate mods offered by the same publisher. At the same time, the malware authors often try to use these mod files as a lure. They get the mod file, they try to backdoor them, or deliberately making it vulnerable to make the end users life hell. So the mod maker is actually one of such scenario. So they actually try to lure the video game enthusiast with some malicious mods. Okay, now what to do? So I open a PowerShell window. Now I'm gonna go and navigate to this directory. Now I have some files against me. I don't have a file utility. That's fine. So I think I failed to install them. So because what the file utility do, if I give file and the file name, it's gonna give me the type of the file. So that's gonna help me to really understand what kind of file it is. But not a problem. We have plenty of other tools to assess them. The first one, which is really interesting, is modmaker v1.4.exe, because that looks like a main file. I need to access this file. So how I can do that? Do I have strings utility? Come on, I don't have. Yeah, I do have strings utility. mc modmaker.exe. Strings is not recognized as the name or commandlet. I need to install strings utility as well. Really? Okay, I think if the strings is not working, maybe I can do floss. Do I have floss here? I guess there is a separate directory. So here I have all the tools that are required. Yeah, you can see floss, kappa. I think this directory is not added in my environment variable, so it is not detecting it. Let's see what are all the other tools we have. We have some dynamic analysis tools, some advanced static analysis tools like Gita. I guess I need to get into this directory before doing these things. Okay, now I have these files. So first thing I'm going to do is using floss. Floss is actually a utility that try to deobfuscate the strings even if it's obfuscated. So it's a string reading utility. So I'm planning to use this floss first against my sample. Okay, so that's the plan. Let's use floss, and I go here. Do I have the sample? Yes, sample danger mc modmaker.exe. Now what it says: Go binary found with version 1.20. Oh, come on, it's gonna be a Golang binary. If I had a file utility, I would have easily recognized it, but it says it is a Go binary, and you can see the version 1.20. Floss handles Go static strings, but string deobfuscation may be inaccurate to take some long time. Do you want to enable string deobfuscation? First I'll give no. If I am not seeing any plaintext stuff, I'm going to give yes. Let's see. Disabling string obfuscation, extracting static strings, extracting language specific Go string, finish execution after, okay, some timings. All right, and I can see some interesting Chinese characters. Cool. Let's see. Just taking it as screenshot. Just it's gonna help me for the thumbnail preparation. All right. Now I got some interesting uh, characters. Wait, can I use less? Okay, I think this is not Linux compatible, right? How about redirecting to some um, some files? So maybe I'll create one directory called within the samples. Maybe if I go and create a directory, I just create a directory with the name analysis, and now I'm gonna go and come on, sample analysis and strings.txt. Come on, how to store these things in file? Do I have an option to store it in a file? Language specific strings, Go, Rust. So it also supports extracting even the strings from the Go binaries. But where is the option to save this in a file? Let me re-execute this. I copy this manually. Okay. And I could see some interesting strings. They are not apparently obfuscated, and I could see them with bare eyes. Come on, how long it goes? It goes all the way. Oh, come on. Is there any way to redirect this outcome? Can I use a simple redirector? I guess it will work. Let's see. Sample analysis flaw start out. How about that? Flaw start out. I guess it's gonna work. Yes. I think let's see. Let's open and see the file. Analysis. Yes, it worked. Need to change the name. Let me rename it. Flaws.txt. Let it be txt file. Come on. F2 txt. Yes, I want to rename this. Okay, now I got the outcome. And let's do this string assessment. But before that, what if I enable the deobfuscation? Do I still see them? Yes. If I give yes, it's gonna take some time. Okay, let it happen. I think there is an option, right? Let me go and see the help menu. In help menu, extract all strings from executable. I think if I simply execute this, it's going to extract all the strings. I guess my current outcome is actually extracted everything. So let's do the assessment here. You can see it's a Go language. It's a Go binary. Golang is used here. Extracted strings, static strings. There are some static strings you can see, and some language specific strings mentioned here. Let's see. So these are the static strings. So let's go through this. I'm just scrolling through. You can see the sidebar. If anything looks unique, I'm gonna stop that. These are all some characters that I cannot understand. And look at this. Syscall control success release string. Okay. Do I see any interesting strings over here? Can I mention the string length at least? Because in strings utility I can mention the string length. N10 I guess. To enable no. Let's see. Can I scroll up and see? I think this one looks okay, right? Defining the number of characters per line. So that is what we use -n10. Okay, I'll do this. Let me tweak this. I'm just gonna close this file floss.txt. Coming a directory back, analysis, getting into the analysis directory floss.txt. So I'm going to rewrite this file with the modified number of characters per line in the strings utility. So okay, now it is done. The results have been rendered. When I press Ctrl O, analysis floss.txt, and now I could see, and you can see the number of characters per line. It's actually holding 10 characters now per line. Okay, it looks easier to read. Let me scroll down faster. And I could see some HTTP reference here. So the malware might be using the HTTP channel as a C2 channel. I don't know. Maybe we will get to know at the end of this assessment. I can see some hashing and encryption standards. The Go binaries are generally bigger compared to the other binaries. If you build your binaries with C or C++, compared to that, the Go binaries are typically bigger. So I can realize that there are plenty of things here to read. And I could see internal ABI kind string. ABI dot and some type and name is blank read variant. Let's see what is ABI. Is this a library on Golang? ABI Go. Come on, I think the internet is not working here. I go to my Sherlock VM. Go ABI. Let's see. Here it is. Go internal ABI specification. What it is? The document describes the Go internal application binary interface known as ABI internal. The Go ABI defines the layout of data in memory and conventions called between Go functions. ABI is unstable and will change between Go versions. Okay. What they say, it is actually an application binary interface. Okay. And now let's proceed. Byte ALG. So why I actually shown some interest here is internal /ABI looks like referring a library on a program. So that's why I've shown some interest doing the research on this. Byte alg. I don't know what it is. Let's see that as well. Byte alg. It's a package. Byte alg is a package. What's the purpose of it? Look at this. So they are importing some library here. Purpose. Do I get to know the purpose? I'm getting some EA assistance here. Let's read through it. Byte is actually packaged in code designed for efficient byte level operations such as comparing, counting byte sizes. Okay, I'm moving on because I need to cover up plenty of things here. OS. A OS library is used in this malware. Crypto library, obvious. So it's gonna be ransomware. So that's why they have used some cryptographical stuff. Math, it's another library, I guess. And encoding, vendor, I don't know what it is, but these are all some libraries, I guess. Some RSA, SHA-256. Moving on. HTTP library, net HTTP. Okay. And I could see the Go files. And I guess the .s file is kind of a library. I don't know. .s file in Golang. I have done Golang assessment before, so that's why I'm taking my time. .s file in Go assembly language. Go is assembly language source file used by the Go compiler. Okay. So these files used by the Go compiler. Moving on. Come on. Some string. Come on. I think here you can see the static strings. Okay, before that I wish to bring another thing, and you can see the kernel 32.dll. So this is the DLL file, kind of a mandatory DLL file used by every executable you see. And this particular DLL file is actually has some methods. So these are all the Windows API calls. So looks like there are some API calls involved in this binary, and you can see the calls, the API calls here. By seeing the API calls, you can deduce what this binary is doing. For example, let's say this virtual alloc, virtual free, or virtual query for allocating a memory on a process, and switch to thread, suspend thread means creating a thread. Suspending the thread, canceling the thread is actually an entity within process, so which is responsible for execution. I think that's my simple understanding at least. So the thread is actually, come on, threads found, what it is. I disabled Windows. I disabled the Defender. So yeah, I think it is disabled, right? Yes, it is. Okay, and you could see the suspend thread, the thread related operation, presume thread, load library, loading the library, getting the system info, getting the process address, exiting the process, creating a thread, creating an event, closing a handle. Come on, get std handle. Oh, come on, yeah. I think these are all the some of the API calls that are in place. So let's go with this false static strings. Bcrypt primitives.dll, kind of DLL related to encryption and decryption, cryptography. Then I could see some meaningless strings. Anything special or any interesting stuffs here? User agent, RST stream, end stream, set cookie, stream equal to okay. Dev standard in create file. Scrolling down. Do I see any interesting stuff here? And I could see some reference to the HTTP transport. I've seen some Chinese characters, right? Do I see it anymore? Okay, so I'll keep these results aside. Let me go and use another tool now. Now, how about using Kappa? Kappa is actually an excellent utility. It is gonna find the capabilities possessed by a particular binary file by just simply looking at its API calls and few other things that I don't know. I just shown the API calls like create thread, resume thread, create process. So by using this, by seeing this API calls, you will get an idea, right? So I guess the Kappa is a tool that works based on that. Kappa, okay, hyphen help, see the help menu, and I can simply pass the binary name here. And if I want more details, maybe I can use verbosity. Okay, now let's do this. I actually need to refer the previous directory. MC, come on. Do I have this sample? Not a sample, right? Is it sample? Yeah. Sample danger, yes. Danger. Come on. Yes. So here is the file. So far we just tried assessing the strings only on this mod maker executable. And now I'm applying the same. I'm applying the Kappa. I'm running Kappa against the same file. So it says it is analyzing the program. So once it is done, it's going to give us a proper result. We have to wait for a while. So okay, let the analysis go. I guess this is the stopping point for this particular part. So I'm gonna stop recording here. I hope you have learned something about analyzing the strings using the tools like Floss. So I hope it's gonna add some value to your malware analysis journey. I'm stopping the recording here. I'll catch you next time with another exciting one. Until then, I'm signing off and cheers. Okay, I'm still streaming, but I stopped the recording. We're gonna start doing the analysis in a moment. So I'm gonna resume the recording, but I'm taking a while to do that. So even the Kappa is taking a while to assess this executable. Let's see. So the malware analysis is not the easy task as you think. So it's sometimes a difficult one. If you are up against a heavily obfuscated, a difficult binary, then probably you will be spending time, okay, with the analysis tools forever. I don't know how many streams it's gonna take to finish this, but I will try my best. Since it's a retired challenge, I also have the write-ups for the rescue, but I'm not gonna use it uh, as easy as possible. I haven't analyzed a Go binary before, so I'm sure it's going to be a challenging task. Okay, I think it's time to start the recording. Hello everyone, my name is Perumal Jagan and we are doing a malware analysis. In our previous parts, I've shown how to set up a malware sandbox. I didn't show it in detail, but I just gave you the reference. And we actually started doing some static analysis. We have used tool like flaws to start assessing the strings of a binary. Now we are doing a challenge called Malevolent Mod Maker. So it's all about a video game mod file, a suspicious executable file that we are up against. Not one executable. In fact, we have a couple of executables, but still we started focusing on that particular mod executable file, and we did the flaws analysis. We have found some strings, and now it is time to bring our assessment further. So let me start sharing my screen, and you could see the screen right now. I am actually running the tool Kappa against the file MC mod maker version 1.4, and it's been running. It's been applying some rules against this binary to find the behavior of this binary. It's trying to deduce the behavior of the binary, and here it is. You could see the whole detail. So let me go and copy the whole string, and I'm going to store this in text file. So let's see this. I'm going to open a new text file, save this as Kappa, come on, caps on, Kappa basic. I'm going to run this Kappa once again with verbosity, so it's going to give us more results. Because let me explain that, but let's see this before. Here is the outcome, and you could see the file hashes here. Analysis static windows. It's a PE file. PE means portable executable file, and the architecture is AMD x86 architecture, and you could see the file path. And here is the Mitre attack technique. So this Kappa is actually working with the Mitre attack framework reference. Mitre attack framework is actually a website where you can see the, okay, I think the internet is not here, right? Mitre. So this is the website. So here in this website you could see the, oh come on, not org, Mitre attack framework. It's been a long time since I have accessed this website, and here it is. So here you can see the tactics, techniques and procedure used by a threat actor, and you can see the stages of attack: reconnaissance, resource development, initial access, execution, persistence. So inside every tactic there will be a lot of techniques, and you can see techniques that are followed by a threat actor. So for example, if I just click a particular technique, I'll be able to see the threat actors who are using them, and you can see their names, the procedure examples. So you can see the list of ABTs, so who will be using this particular technique. So this is the Mitre framework is, and this tool Kappa is actually working closely with it is actually an integral part. The Mitre is actually an integral part here, and you can see a defense evasion. D of escape, decode files and information. Okay, shared modules, anti-behavioral analysis, communication cryptography, debugger detection, software breakpoints, HTTP communication reader header, crypto library, decrypting data with AES, encrypting data with these schemes, and hashing is 256, SHA 256. generate pseudo random sequence RC4, hashed message code, check string, encode data XOR, non-cryptographic hash, defense evasion, obfuscated files and information. Okay, okay, here are the capabilities. Check for software breakpoints, anti-analysis, anti-debugging, and debugger detection. Parse credit card information. Okay. Check HTTP status code. I think HTTP is the C2 channel. Compiled with Go binary. Encode data using add, XOR, sub operations. Encode data base 64, EAES. So more encryption and encoding. Hashing functions. Authenticate HMAC. Get kernel 32 base address. Okay. Enumerate PE sections. Resolve function by parsing PE exports. I think I would have ran it with -VB now. Meanwhile. But anyway, let me analyze it again. It's going to give me more details, but this time I'm going to store these details in a file, right? So let me redirect it to a file, samples, analysis, kappa detailed.txt. So it's going to store whatever the result is. The result is going to store in this txt file. So I'll open a new tab. I don't want to disturb it. And now what I can do, I think I can probably start doing more static analysis. So let me use another tool called P Studio. Do I have P Studio here? Let's see. Static tools. PE I have. P Studio is also I have. And I go here. I run P Studio. P Studio is actually an excellent tool for static analysis of a malware. Okay, so I go open the file. Let's see. Yeah, here is the file. It's a GUI utility. So I'm loading the file, the malware, sample, danger, MC mod maker b 1.4.exe. I open it. So it's gonna do some intelligence, the threat intel for us. So it's gonna reach virus total, it's gonna reach some malware database to bring some file hashes and compare it with the current hashes we have. So it's gonna give us the results here, but let's see that. But before that, so here is the DOS header, DOS stub, the components of portable executable file, and the file header. And you can see the file header here. What are the characteristics? File can be executed. It's an executable file. So here is the timeline. Jan 1, 1970 UTC 000. The timing is 12 o'clock exactly. I don't think this is actually an authentic time. I think they did some time stomping. Time stomping is actually the process of tweaking the time to dodge the security analysis. AMD 64 is the architecture, the supported architecture. Optional header. Okay. It's been a long time since I did this PE analysis, so I might be struggling in between. So bear with me. OS version, it says Windows 7. Directories for iData, pdata, relock, and .data. Okay, let's see the import section, and here is the thing. And you could see the library kernel 32.dll and the list of imports. The functionality is imported from this library. Load library. These are all the things we've already witnessed. Exiting the process, creating the thread, closing the handle, virtual lock, writing the file. So looks like it is also tampering with the file. So the ransomware, what they typically do, they try to encrypt a file and just try to change the extension to a different or weird string. So when a user try to access the file, it's already tampered. They're no longer able to access them. I don't know what happened, so it terminated quickly. So I'll reload this. Okay, and here it is. I think this is what I was looking for. It was not properly opening before, and I could see the flags here. So if I go to the import section, in the flags I could see some imports with red flags, writing the file WER set flags. So what it is? So let's Google it. WER set flags. It's an API function. What's the purpose of it? The fault reporting settings. You can specify one or more following values. Kind of a false reporting. Virtual query, virtual alloc to allocate the memory. Switch to thread, suspend thread. Set control handler. Set thread context, get thread context, environment settings, get current thread ID. Vector exception, add vectored exception handler. Let's see. Add vectored exception handler. So this function belongs to this library. The order in which the handler should be called. Okay. So there are some red flags here. That's what I wanted to mention. And here is another important and interesting part. Sections. .tx, .text, .rdata, .data, .pdata, .xdata. I think all these things has some meanings. I'm not positive like what it is, but you can see every section is not having the same same privilege, and you can see here the .text section is having executable privilege. .data is having the write privilege. .idata is having a write privilege. I think there is a standard thing for this. So one particular section should not be having this kind of privilege, and this section is having only this privilege. So there are some standards for that. But here there is another interesting stuff is, oh come on, process termination. Okay, if I click OK, it's gonna close, so I'm not clicking it. Maybe until I read this. There is a portion called entropy. The entropy is actually, if typically it is higher, then I guess there are some abnormality. There are some anomaly in that. I guess there is a limit. I'm not sure it's a 7 or 6. The entropy limit. Entropy limit in malware analysis. Zero to 8. Files with entropy score above 7.2 are frequently flagged as potentially malicious. So I don't see any of the files with more than 7, but I could see one section with 6.2, so which is little suspicious. Okay, and I could see some import flagging here. Apart from that, I don't see anything else. So what I do, I simply click OK and close this. I don't know why it is keep closing. It's weird. Static tools, PE Studio. Um, the PE Studio is keep behaving like this. I'm gonna switch it to PE Pack, which is another similar tool. Okay, now you could see the same stuff. A library, just one library got loaded. I don't know whether this binary is actually showing the things that I want. Maybe I can use a tool called DIE. Because the DIE is detect it easy, it's gonna predict is there any packer is used. So let me tell you what is the concept of packing. Packing is actually the term packing. What it is generally mean, enclosing something, enclosing an object with something, right? So that is what this packing term in malware analysis also. Okay, the same thing. Okay, I think I'm struggling. I'm just trying to explain this in a better way. Packing means enclosing a binary, hiding the binary with something. So they actually call it as a packer. In malware analysis, the term is called packer. If a malware is packed, then when you just try to analyze the packed malware with some tools, then you won't be able to you won't be able to read much details. So what you need to do, you need to unpack the malware before you start assessing it. So that is what called packing in malware analysis. There is a tool called DIE, detect it easy, to open a file with you can open the file here simply, then it's going to give us whether the file is packed or not. So it's going to predict that. The sample danger, I go to this modmaker.exe and here it is. So it is also giving me the details of the language. So it says it's a Go language, Golang binary. The language is Go, and I could see the architecture, the NDNS, and the type of binary. If I see detect it easy, let's see. I guess you need to apply. You might apply some Yara rules as well here. The Yara rule predicts some encryptions here, and can I see some packing? I don't think this is a packed binary. Otherwise, we would have seen the results here. Options, file. Okay, let's see. Yara, extra database, deep scan, signatures, hexadecimal. This has some online tools. You can see the virus total API key. So you can just integrate this DIE tool with virus total. If I click advanced, if I click demangle, demangling means deobfuscating the things. But if I click advanced, I could see more details here. The file size is 5.29 MB. The strings, disassembly, hexadecimal. I could see all the details from here. So it's a useful utility. Let's see. Entropy. Let's see them. So this is the highest value, and it says the status is not packed. I guess this one says these sections are not packed. So there are 78% of chances that this file is not packed. So that's what we presume. Memory map. So I'm just trying to learn these things, this tool. And you can see the hexadecimal format, MZ. So this is the magic byte. So the 4D5A is the magic byte. So this is the magic byte for executable file, the PE file generally. So that's what it is. And what is extractor? I don't know. Yes, it's a hexadecimal representation. Disassembly. So here it is. So the disassembled code, the disassembly of the whole binary. Visualization. Excuse me. Sections, yeah. So the section wise data. Okay. Imports, yeah. The import and its address, I guess. The memory address. The base address entry point is given here. The timestamp I could see here. File info. So this is the file. All right. I don't think it is bad, but let's see. Let's do further assessment. Okay, I'm not going to use it now. What else I could do? Maybe can I try to answer some of the questions? I don't know. Let's see. I go to the VM, go here. Let's see. Right from the start, based on the incident details, the .txt file contents and the extension applied to the .txt file, what type of malware infection this is. So we have seen a file with some weird extension, right? So that's what they're asking, I guess. Sample, danger, folder, and you could see Go team. The file extension is Go team. Looks like this one is actually a file, the text file, probably important.txt.go team. Go team means that extension, the malware extension. So as I said, they have encrypted this file followed by this extension change. So they changed it to Go team extension. So let's do some open source, some OSINT, open source intelligence, and also I'm planning to find the file hash to do some probably some open source intelligence with help of VirusTotal. Let's see. So here is the SHA-256 hash, copying the value. So I have copied the file hash, and okay, the internet is not there. I keep forgetting it. And so here is the file hash. Let me go to VirusTotal. I think that's the promising website. And what this particular website does, so in this website you can search with the URL, file hash, even with the file, whether you can check whether the file is recognized malware or not. And look at this. Here is the file, mod maker version 1.4.exe. It's a known malware, and they say it's a stealer, or I don't think it's a stealer, it's a ransomware. But let's see, let's go and see the community entry. And here I could see the malware family name, Luca Stealer, Frosty Goop, Dosia. Frosty Goop. Let's search with this malware. There is a Unit 42 blog by Palo Alto. Frosty Goop malware analysis. Frosty Goop, a closer look into the malware behavior and network communications. It's an OT malware, they say. Bustler become publicly known as attacker used to disrupt this. Okay. Um, Frosty Goop is compiled using Go programming language. So this is the Go malware, right? Sometimes referred as Golang. Malware uses relatively obscure open source Modbus implementation. Um, so the Frosty Goop might be the name. Let's see. Um, can I go and answer this? No, this is not Frosty Goop, it says. Um, so here are some static analysis. Bustlebomb. Is it going to be the answer? No. But in Virus Total, what we have seen, Frosty Goop, Knight, Luca Sealer, Dosia. What is the question? What type of malware infection this is? So they are asking the what type of malware infection? Ransomware. Is this the answer? Yes. So they are asking the type of malware. It is ransomware. And what mechanism does MC modmaker.exe use to send information back to C2 server? You can either prove it via dynamic analysis. I guess HTTP 6 characters. What command does MC modmaker run, suggesting that it means to execute other binaries or scripts? What is the API key value? I think we need to do further analysis on this binary to answer these questions. But for now, this is a ransomware. Okay, it keeps stopping. PE bar. I open it with PE bar. File, load PE, and I go to samples, danger, modmaker.exe, and this is also loading the same stuff, and I could see some lesser details. I don't see any flags, red flags in this analysis. Okay, so what we need to do next? So let's see what are all the other static analysis options that are up against us. I can use a cyberchef if I find any encrypted stuff. Kappa rules. PE Studio I already did. Yara and Floss. So maybe I can go for the advanced static analysis. I don't know how much I'm gonna get through it, but maybe I think I should be able to do some reference here, because I haven't done the Golang analysis before, because it's quite difficult than the C++ binaries, assessing C or C++ binaries. You might need a separate extension for that. But I guess for now, what mechanism does this incentivize the C2 server? I'm just thinking how I can crack it up. Let's see. Even if I use some advanced tools like Ghidra to disassemble them, I don't know I'll be able to understand anything. Okay, let's go and see this. I did the static analysis with Floss, right? Not Kappa. Sample analysis, Kappa detailed. So what I could see here, do I see any interesting stuff? Author Michael Anhoff Mandiant. Anti-behavioral analysis. So behind each of these guesses, there are some reasons. So that's what they gave here. That's why I had to use -VV for the verbosity in kappa. Scrolling down, check HTTP status code, and look at this. Check HTTP 2 matches. Communication HTTP client. Author this one. Function. So here is the function address. Maybe when I do the advanced static analysis, I can directly navigate to this address to see the HTTP communication details. I think it could be used for that. All right. I think this is the stopping point. We are already reached the 30-minute mark, so I'm stopping my recording here. Hopefully, we'll be able to get some big breakthrough next time when we are doing this analysis further. Okay. So let me stop the recording. Yeah, actually I forgot to mention one thing. Do this YouTube algorithms, like, comment, subscribe. I am catching you next time with the same malware analysis. We are going to continue further, so we're going to track this stuff. Okay, I'll see you next time. Thank you so much. Okay, I have stopped the recording now. Yeah, I think we are doing some job here. We are on the stream right now, so let me go and take a look at the other questions. What domain is the C2 server or ransomware payload? So I'm quite curious to understand like how to access this Go binary. So I'm planning to check the write-up, because I don't hesitate, because even if I go and use Ghidra to open the binary and read them, I'm not going to get anything. But I think I'll be able to read through the official write-up. But don't forget, we also have other binaries here which is yet to be analyzed. The bruh.exe, goteam.exe, right? So let me go and load them as well. I think if I go to signature, can I read the oh, come on, info view, compare info? Do I get any interesting info here? Okay, so I close this stuff, unload all exe, and closing this tool, I go to the tools. So before I start my next recording, I wish to get some clarity here. I can do this dynamically. I can run this binary in a dynamic sandbox. I can start starting the tools like procmon and execute the binary, but it's going to execute the binary and going to give me the domain name, so I'll be able to see them. But I want to understand in depth how we are going to find it, maybe by doing simply the static analysis without going to the dynamic analysis. So that's what I am focusing on right now. Static tools, come on, pstudio.exe. Opening the file. How about opening this goteam.exe? Looks like the encryptor, right? I'm not sure. Let's see. Copy the value. So we say this is a ransomware, but by seeing that MC mod, the main binary, we got to know it from the virus total verdict that it is probably a stealer. But it is not necessarily be a stealer. It could be a dropper, right? Dropper means a malware used to download other files into the system. So we have the goteam.exe, right? And you could see this one is actually the ransomware. I could see clearly this is actually the ransomware. Yes. So why don't we run the same kappa and other things against these two files as well? Goteam and brew. So let's do that. In Goteam, if I go to import, I could see bunch of stuffs. Sections, strings. Okay, I guess what I feel is, so this is the main binary. When it executes, it is downloading the ransomware binary from the C2 server, and that ransomware is actually goteam.exe. That's the name of the file. And what about this BRUH? I'm not positive. Let's see that as well. Sample danger bru.exe. Let's see. Come on. I open another tab. So here in static tools, I go to pstudio.exe, file, open file, bru.exe, just to get the file hash of it. Copying the value, going to the sandbox, virus total, pasting the file hash, YAML attribute malicious high confidence. I don't see any community detail. Okay. Now I guess I could at least say like what I should do, but before that I wish to see the write-up, because I don't feel shame to refer this write-up, because anyway I'm gonna learn this, right? The Sherlock case involves a malware incident where seemingly innocuous program shared with the gaming community turns out to be malicious. Program disguised as mod making tool executed by senior software engineer loading ransomware attack. The malware encrypts the file on victim's machine and demands a ransom for a decryption. So that's the typical behavior of ransomware. Through this case, the investigators will analyze the provided artifacts to uncover malware's behavior, including its communication with command and control, execution of additional files. And here is the official write-up. So let me download this. Can I download them? Malware analysis, malevolent mod maker, and here is the write-up. I'm saving it. All right. So the description, the scenario, and the file, the different file hashes. D.ext is actually another file. I don't know what sort of file it is, but here is the file, encrypted file by the file encrypted by ransomware, and another file. The first step they do is gathering the file hashes, so which is essential. Skills learned: malware analysis, basic reverse engineering, and basic cryptography understanding. Okay, so what they did, they actually used a tool called hash my files, and they tried to find all the file hashes. Okay, so the first question, txt file, go team, to get your files back you got a, but how did they file this content? How did they find the content of this file? Contents of .txt file. Come on, let's go and open the txt file. I suspect that's gonna be ransomware node. So this is the note here, right? So let me open this txt file. Yes, here it is. A ransomware file. It's a ransomware note. So it's ransomware. Type of malware specifically which is common for the ransom. The ransomware typically demands Bitcoin. Okay. What mechanism does the mcmodmaker.exe use to send the information to the C2 server? I think they're answering this via an advanced static analysis. They are opening a file in a tool like Ghidra. So from there they are seeing the URL. So they say it as a webhook. What command does this exe run, suggesting it's meant to execute other binary source script? In Cutter, actually they are using the disassembler called Cutter, but we can also use Ghidra. There is also a function called run command on the host. So they are getting into that particular command to see what are the commands ran by the malware. So they are just trying to answer them via the static analysis, the detailed static analysis. What is the value of API key contained in the URL suggesting the enumerated geolocation data? You can see there are two curl commands. One is connecting to this. Okay, maybe trying to answer via strings. What's the C2 server? The ransom payload. The other curl command is downloading the key from Go team. Okay. While analyzing the modmaker exe, what format is the data that returned to the C2 server? Send to discard inside the okay. So, and here they are coming to the malware, I think the dynamic analysis. The sixth question. After detonating the malware, we can open procmon process tree to see all the commands run by the malware. And here is the whole thing. Checking the Wireshark on my Remnux host, we can see the DNS request to Discord app made. What specific file type is enumerated by goteam.exe for encryption? So the second file analysis team enumerates the restricted Windows folder. With the encrypt file function, in case file is successfully, what is the name of the instruction? What is the decryption key? And we already saw the answer in the okay. What is the name of the project is encrypted.txt file? See key. Now open up. Okay, let's see. The brew file is actually looks like a decryptor. Okay, now I guess it is time to start our next recording. So what I felt is most of our questions can be answered by using disassembler. So let's go question wise this time. I guess we will be able to crack this quickly. Okay, the malware static lab is up. The malware dynamic lab is also, I need to start, but I think the static analysis we do in this stream. Okay. Okay, what I do, I go to the Sherlock. Here, what mechanism does mcmodmaker use to send the information to C2 server? So I need to use disassembler. The HTTP is the stuff. Okay, now what I do, I'll start recording. So let's see. Alright, I'll start the recording now. I was not sharing my screen when I was referring the write-up, so hopefully keep that spoiler free. Okay, now I start the recording now. So it's gonna be the last recording, I guess, in this particular stream. Hopefully I'll be able to continue from the next stream. Hey there, my name is Permal Jigan and we have been doing a malware analysis. We are trying to analyze a Golang malware. Looks like a mod maker executable, a video game mod maker, and we are trying to assess them. Earlier we did some flaws, kappa analysis. We tried opening the binary with P Studio, yet we need to find few more details, right? So we need to answer a lot of questions. We just answered one question before, so let's go and continue analyzing this stuff. So I started sharing the screen again, and you can see this particular caution note. And now we are up against three binaries: bruh.exe, goteam.exe, and mcmodmaker.exe. So this is the main binary. So we did static analysis on this binary alone so far, and now let's go and check out this bruh and goteam executables as well. So what I'm planning to do, I'm planning to run this particular command, both flaws and kappa, against these binaries. Okay, so that's the plan. I go here, change the executable name, goteam.exe, and the flaws output for goteam binary. So it's gonna get stored in this file. Fine. I go here. Okay, it already stored. And now I go and do the same for bruh file, bruh.exe, another binary, bruh. All right. Now I do this against this file as well. It is done. Now I go and do kappa. Kappa is actually a utility to detect the capabilities of a malware. So that's what I'm planning to do now. goteam.txt kappa goteam. That's gonna be the file name where I'll be storing the outcome. Fine. I run this. It's gonna take some time. So meanwhile, I copy this command. I go here, try to do the kappa against the remaining binary as well. Come on. What's the binary? bruh.exe. bruh.exe. Not recognized. Wash. I guess I should switch the directory to this. I'm from the different directory, so that's what causing this. And now if I go and start running this, it's going to store the results, kappa results, into a file. Okay. We close this. Now let it run. So once it ran, we will come and assess the results. And for now, I'm going to open Ghidra to do the static analysis of this malware. So first thing is I need to do this modmaker.exe. But before that, have you seen this txt file? It's a text file. If I had the commander utility on the file utility, I would have checked it, the file type, then I would have opened it without fear. But since I already referred the write-up, I'm gonna go and open this, and here is the ransom note. Ha goteam, to get your files back, you gotta pay 1 Bitcoin to this particular address. We will give you the decryption key. Then you run following command from the folder bru.exe -key and the decryption key. So they also gave a way to decrypt the data. bruh.ext is the decryptor then. So the binary is a decryptor. So there is no sense in analyzing that particular binary anymore. So I'm going to leave this analysis behind. Instead, I'm going to focus on analyzing MC mod maker and goteam.exe. Okay, so that's the plan now. So the first thing is I'm going to do the disassembler. I'm going to use a disassembler to assess this MC mod maker version 1.4.txt file. Okay, so that's the plan. So let's go here to the tools, to desktop, advanced static analysis, Ghidra. So let me run Ghidra here. Come on, I think the batch script. Okay, I'm running Ghidra now. So I already installed them. Close and new project, non-shared project. Let me go and choose the same directory. Desktop, sample, danger, not choosing this one. Come on, I go here, desktop, sample. I create a directory called Ghidra. Within this directory, I'll store this detail. And the project name is ransomware, maybe. Just keeping it simple. Now I'm opening the Ghidra. Okay, I think I should press I to load the file. This is correct. Import file is I. Correct. Now I go to desktop. Come on, sample, danger, mod maker v 1.4.txt, and it says it's a Golang binary and options. There are some plugins, some add-ons to use in Ghidra when you are accessing Golang, but I'm not positive what it is. But maybe if I know, I would have installed that as well. But I think it's gonna work. Let's see. If you want to allow public file, okay, cancel. Hasn't been analyzed. Would you like to analyze it now? Yes. So what type of things we need to analyze? So we can choose them. I'm just keeping it default. modmaker.txt, and you can see the modified file time, which is current date, and compiler is GC, they say. Golang, Go version number. Okay, I guess it loaded, right? Look at this. It got loaded. Yeah, it got loaded. I think now we are in the entry point. Going to the functions. Can I see any interesting stuff here? Any main function sort of thing? So this is the entry point. Analysis found symbol entry. Would you like to go to the symbol? Yes. Based on the function, I'm not sure what I'm up against. I haven't done this on stream before, so I feel pretty nervous to do the disassembly of a Go malware on stream. I never imagined I would be doing it. Okay, let me close this. Namespaces, classes, labels, exports, imports. If I see import, these are all the imports, the imported methods. Sherlock, what it is. I don't know here which one is responsible for the HTTP communication. Because I need to investigate from this question's point of view. What mechanism does modmaker.exe use to send back the information back to C2 server? So from these results, I could see, so it looks like it is using HTTP as the medium to send the data, right? Kappa Go team. Okay, let's see the floss Go team. So in the floss Go team file, do I see any interesting stuff? Let me open previous floss detail. In the previous floss, in the modmaker floss detail, I'm just searching for HTTP because I would like to get the URL or the HTTP method, right? The string is gonna give me some valuable things, and here it is. You could see the URL, right? Yeah, look at the URL: http://goteam.htb 8080. Looks like the potential URL that actually gets the goteam.exe binary. So looks like this is the URL that grabs the goteam.exe, that downloads the goteam.exe. Yes, correct. So this is the stuff. You can see they have used curl to grab it. Curl-output goteam.exe, and they are just sending request to this URL. So it's clear that this is the URL. So this is the note that I'm planning to take. Notes.md. Come on, saving it as notes.md. Notes.md, and looks like this is the command used to grab the goteam.exe file. Maybe can I do any string search here? Search for strings. Yeah. Come on. Okay, here is the string search. Can I do some filter? No, not a filter. Yes, here I guess I should be filtering it out, because when I filter that string name, I'll be getting the address. So if I go to that address, I can reach the spot in this disassembly. So it's a big binary, so it is not possible to do it manually. So this kind of things we should be using. Okay, now I go to the kappa detailed output. So this will be storing the kappa, the capacity, the kappa analysis of this modmaker binary. And here, if I go to HTTP channel, maybe I can go to Go team or curl. Can I see? Let's see. Come on. Um, HTTP or C2, can I say? Communication. Yes. Communication HTTP client. So this is the address. So I'm going here. Can I go to this address 650CA0? Not I. To search a thing, I'm not. I'm not a Jira guy. Haven't used it before. So maybe if I go check for this address 650CA0. Let's see. 650CA0. Can I see them? Come on. (650CA0) and let's see. Can I see them? (650CA0). Yes, 650CA0. Next time we are doing any malware analysis, I'll come up by learning this Jira basics. I don't know what key to use here. 650C. Come on. We are almost there. And look this. 650C is 0. And look at this. This is what I was looking for. And here is the data related to this HTTP client connection, right? So I'm just clicking that. So it is redirecting me to the status text. I don't know what it is. Let's see. HTTP status text. So let's see what is our question now. What mechanism does mod makers to send the information back to the C2 server? Let's see. Can I see any other HTTP related stuff here? Because I'm just trying to find a way how to navigate that particular spot. I know the answer. What is the answer? I know that, but I want to just show you how I can search for that. If I search for a string, okay, and how about looking for something else? Let's see. I open one more file, Kappa basic. So in this file, I could see the HTTP status code, software breakpoint. I guess this is what is related to the C2, right? I'm just trying to understand like how I can in the disassembler how I can get to the part. So because in the disassembler in the string, if I go and see, I'll be able to uh, witness the uh, answer. I'll be able to see the answer, but come on, net HTTP. So this one's okay. Control F to search a string. Yeah. How about seeing Go team? I see them. Search all. No, I don't see them. Control F. Webhook. So this is the answer. I know it already. So I'm just trying to search them. I don't get it. I don't get them either. So I need to learn this Golang analysis. To be frank, content length. So the HTTP library is actually content length. Okay. If I scroll down, multi-return, pointer runtime. One more time, calling HTTP, content encoding. Okay. Then scrolling down further, content encoding, string. Okay. Content length. Function flags, S2 bundle, HTTP client. Okay. Scrolling down further. Fingers crossed I'll be able to see the string that I want. Oh. It's massive. I need to find a way to search it through. Mutex. So mutex is actually a term in advanced malware analysis. I'm not positive what it is, but I need to learn them. Go panic. Still going. Graphical view. Let me refer the write-up. There is nothing wrong in referring the write-up. Yes. We are learning at the end of the day. What mechanism does use to send information back to C2 server? We will begin with ModMaker EXE. We can load this malware into IDA cutter to begin disassembling. Within the main function, we can see that this is likely using Discord as a C2. But I did not see main function, right? Did I? Can you see for a word main? Can you search for a word main? Runtime main. Is this a program? Main. Is this the main function? Yes, it is. This is the main function. Oh gosh, how did I miss it? If I go to the functions, I don't see the. I think I need to expand this. Oh gosh, I should have expanded it, right? Or did I overlook? Where is the main? Can I search through this? Can I search through these functions? No. Expanding everything. Do I see main function here? No. But when I search here, Control F and search for main, search all. So here this one lists the main function, and I could see the source. Okay, can I just bring it aside? Yeah. And here is the main.go, the main function. And when I get into the main function, here I could clearly see send to Discord app, API webhooks. So looks like it is using webhooks. So that's the answer, apparently. So that's what given here. So it's a webhook. Based on the partial URL, we mean that the send data back. Okay, based on the partial, this means that the send data back to the actor's Discord server via webhook. So that's the obvious answer. And what is the value of API key contained within the URL which suggests to enumerate geolocation data? So the geolocation data enumeration, let's see how to find them. In a cutter, we can see that there is also a function called run command, suggesting that the malware runs command on victim host. Okay, I think this one. What command does execute run, suggesting it means that they execute other binaries or scripts? So I think I should have seen a function related to execution, right? Can I see any of such function? Run command, because that's what he mentioned. In Gita, do I see that? Read, write to, go, switch index. Okay. I don't think we see run command here. But what's the question now? What command does this executable run, suggesting that it meant to execute other binaries or scripts? But by referring this write-up, I'm not getting the proper answer, because they are simply searching with run command. In Cutter, they actually see the function called run command, but in Ghidra, I don't know whether I'm looking in a wrong place, but as per my knowledge, I don't think there is a function called run command here, because whenever you open Ghidra, this is the first place you wish to look. Call return. What if I look the main function? Control F, come on, main, search all, scroll down, moving back to the main function, and so here are the functions. I guess if I choose Control F, search for functions. Okay, I search all the functions with this name. Search all. Okay, here self, what it has. Send to Discord. So this is the function that we had, right? And in this function only we have seen the, okay, sorry, in this function only we have seen the webhook details, the URL, right? But here is the command. Look at this. I think I shouldn't be searching here. Instead, I should use Control F, then search for the function. And if I go to run command, probably I'll be able to see the command which actually executed. So here is the run command. In the run command, okay, let's see the disassembly here. Can I see the command which ran? Runtime new object, execute run command. Send to Discord. I go here to the Sherlock. Sim go main run command. 6724F8, the address. That means I should scroll down. 6724 F8, and that's the address. Let's see. Here is the 6724F8. Come on, I'm just going to the memory address. F8. Okay, here it is. This is the function call. So now at this point it is calling 67F4. Yeah, 6724F8. At this point it is calling the function, and I could see the function here, the function definition. But in this function definition, do I see the answer? And this malware uses curl command to retrieve ransomware binary, presumably send the host back to the data. Basic post enumeration. Here at the bottom of the image is the intriguing strings. We look at the commands purpose of the PowerShell. Okay, and execute other binaries or scripts. So out of all these commands, they say this particular command is to execute the other scripts, right? So that's what they meant. And how we can get into this part? So they got into the run command, and within the run command, that function definitions, I think they are seeing everything. How to look them in Ghidra? Like what are all the commands executed? This. What if I choose the graph? Within the graph, can I see this? Yeah, run command. And within the run command, and I could see some definitions here. Parameter 1, parameter 2. This function is what doing this run command. If I scroll further, can I see any detail? I think this is what they were talking about, right? Let me go and see the write-up. 6724F8, and here if you see, there are a bunch of MOV and LEA command instructions. MOV and LEA. So this is the block, but if we go here, so in the main run command 671F55, so I should go there. 671F55. 55. So this one. So in this, All right, I think I'm gonna stop this stream here. I'm planning to use Cutter because I haven't used Ghidra often, so that's why I'm struggling to find the stream here. Maybe I can. What if I search for a specific comments or labels or all fields? What if I search for what is that? PowerShell or bypass? How about that? So it's gonna take time because there are plenty of things to search. Yes, I'm gonna cancel this. In the selected stuff, I gotta search commands, labels, and look for bypass. Can I see something? So it is still searching. It's going to take some time. Okay, I guess I'm going to stop it here. So we are learning some crucial reverse engineering, how to reverse a binary by using Ghidra. Though I couldn't get all these things right, hopefully I think I did learn something for sure. How to use the disassembler to navigate those things. Maybe in the next stream I'm planning to use Cutter and the other stuff. Let's see. But for now, it is time for me to signing off. I'm gonna sign off. Hopefully, I think we have learned something from this. Now, I'm gonna sign off. I'll catch you next time with the other exciting scenes, and we are going to continue this malware analysis stuff in our next stream. Hopefully I'll be able to record more videos then. All right, I'm signing off. Cheers, and I love you all. Thank you so much. Okay, the recording has stopped. Now it is time to stop my stream as well. Thank you so much guys for joining this stream. I struggled a lot, but I'm not gonna leave anything behind. I'm gonna include every struggle, everything in my recording as well. So I'll be launching part by part video from now on. Okay, now I'm gonna end this stream. I'll catch you next time with another exciting one.